Hello everybody. We wanted to start by taking a look at the different components that we will be using in our project. And we're going to start by just quickly reviewing all the components, and then we'll take a closer look at each one. To start with, our first component is something called a breadboard, and this is used for showing or making electrical connections to some of the other smaller components in our project. The next component is our liquid crystal display used for displaying information. Then we have our potentiometer, our resistor, a thermistor, our microprocessor, which is an Arduino compatible Elegoo Uno processor, and then finally we've got a little DC motor with some fan blades in the back. So these are the components that we are going to be working with. Let's take a closer look at some of these. So our first device is the breadboard. And the breadboard is kind of a neat component in our project in that it allows us to easily plug in various components and make electrical connections between those components. Now the breadboard is organized into buses and bars, okay? The buses are these blue and red lines running down the length of the breadboard. And you'll notice that I've got a blue bus on either side. There's one down here at the bottom, and a red bus. As I touch one of the holes in the blue bus, you'll notice that all of the blue bus holes are connected to one another. So making a connection into this hole basically connects with all of these other holes. The same is true for our red bus. Make a connection here and you basically are connected to all of the other holes on the red bus. And the same is true down here, down below, for our red and blue buses. Our bars are in the center here, and there are two groups of bars. One of the things that you'll notice about the bars is that the columns are numbered. So starting with 1 up here, then in groups of 5, 10, 15, 20, 25, all the way down to 60, and then finally the last button here is 65. The rows are lettered, starting down here with A, B, C, D, E, F, G, H, I, and J. Now the thing about the bars, unlike the buses which were running horizontally, the bars run vertically. So I touch one connection, notice all those light up. I go to another one, touch it, all those light up. So everything in yellow is interconnected here. Let's touch a middle one and you'll notice all of those are lit up. So these are your buses and bars, and we'll be asking you to make connections into or connecting components into the holes of the breadboard. Our next device is our computer in this project, and specifically this is a microprocessor. Often this device goes by the name Arduino Uno, but we've purchased it from a company called Elegoo. So this is called an Elegoo Uno, but they are essentially the same device. All of the connections and the workings of this device are the same regardless of whether it's an Elegoo or it's an Arduino. But here is the actual processor itself, and then all of the other components here are simply supporting circuits. I'm going to switch over and show this in another view so that it's a little easier to see some of the connections. So here's our processor again, only this is a graphic image of the layout of the actual processor board, but it's a little easier to read. So again, you've got the processor in the middle here, and you can see that right here. And then up at the top, you've got an electrical connection which allows us to plug a battery in, and then a USB port for connecting our processor to our PCs or computers. Over here on the left, we've got our connectors. You'll notice that they are numbered A0 through A5, and we refer to these as analog in. You also have connectors for voltage in, ground, 5 volts, 3.3 volts, a reset, and an IO reference. On the other side, our pins are numbered, and you'll see that there are 2 groups of pins. The first group goes from 0 to 7, and then 8 through 13, with finally a ground and something called an A ref. There is also an LED on the board to indicate power, and we can, that we can actually control. We can turn it on and off, as well as a power LED right down here towards the bottom. All right. So again, this is our computer in the project, and we will be making all sorts of connections to it in just a little bit. The next device that I want to talk about is our LCD, or liquid crystal display. And this is going to be used for displaying our output from our computer. And this particular display provides 4 lines of output with 20 characters on each line. The connectors on this device are on the other side, and here they are here. So you've got these pin connections here, and they're numbered or identified as ground is the first one, then VCC, which is your voltage, then SDA, which is the data, and SCL, which is a clock signal. And we'll go into these a little further and where they connect to our microprocessor in just a little bit. So that's our liquid crystal display. Next, we have what we call our potentiometer. And our potentiometer looks like a little control knob. In fact, you'll notice this knob right here, and it simply turns, okay, and allows us to change a setting. Specifically, we're going to be using this potentiometer for setting the desired temperature in our cooling system. Now, the potentiometer, in addition to the knob here, also has 3 electrical connections. So you've got 1, 2, and then 3. And we'll be taking a closer look at these connections as well as we wire up our project. This next component is something called a resistor, and specifically this is a 10,000 ohm resistor. Resistors in electronic circuits or electrical circuits are used to limit the amount of current that is flowing through a circuit. As you can see, our resistor has a body here with colored bands, and it's those colored bands that actually tell us the value of the resistor, whether it's a 220 ohm, 1,000 ohm, or in this case a 10,000 ohm resistor. And then it has 2 connectors or leads on either side, and quite honestly it doesn't matter which side is which. You can basically turn this thing back and forth, and it really doesn't matter how it gets plugged in. Okay, so this is our resistor. I'm going to take that and move it away. Our next component is something called a thermistor. A thermistor is very similar to a resistor in that it does limit the amount of current that is flowing through a circuit, but it's special because it is affected by temperature. Okay, so as the temperature goes up and down, the resistance that the thermistor provides goes up and down as well. Okay, this little component right here, and you can see the point of my pen, this little component is going to help us to determine what is the air temperature and then feed that information to the computer to make a determination as to whether or not to turn our cooling system on or off. So this little device is capable of telling the temperature, okay? And it's used in conjunction with our resistor. So these two will be working together to help us monitor the temperature in the room. Our last component is a simple DC motor. And the motor, the body of the motor being right here, has a small fan blade attached to it. What's nice is that these blades are made of rubber, so when they spin, if you happen to hit them with your finger, they don't hurt, okay? The motor has attached to it two electrical conductors that we'll use to plug into our microprocessor and to turn our fan or our cooling system on and off. Okay, so these are all of our components. Next, we'll talk about plugging the components in and starting to build our personal cooling system. So let's get started in building our personal cooling system. And the first step that we're going to take is we're going to get our breadboard. That's this white thing right here. And we're going to install our potentiometer. Remember, that's the knob thing that is going to help us to set our temperature. And again, remember that the potentiometer here has 3 electrical connections. And what we're going to do, those are 3 little pins, and we're going to plug them into the breadboard. It's important that you be careful as you do this because those pins are not particularly strong. So what we're going to do is we're going to line up with the 60 right here, okay? So you can see the 60, and we're going to plug in right here, and I'm going to push this down nice and even. And there we go. Okay, so that's our first component that is plugged in.